Why don't you fall through the floor? That question sounds almost childish. Of course you don't fall through the floor. The floor is solid. You're solid. End of explanation. Except that explanation doesn't explain anything, because the moment you stop and think about it, solidity becomes deeply strange. Atoms are mostly empty space. You've heard that before. Nuclei are tiny, electrons are spread out. Between them is almost nothing. So if both you and the floor are mostly empty space, why don't you pass straight through? Why does the floor feel hard? Why does it push back? This isn't a philosophical puzzle, it's a physical one. And the answer is not what your intuition expects. The first mistake is thinking that solidity is about touching, about atoms bumping into each other like tiny billiard balls. That picture is comforting, but it's wrong. Atoms don't touch. Not in the way you mean. When you stand on the floor, the atoms in your feet never make contact with the atoms in the floor. They don't collide. They don't press together. They never meet. And yet, you don't fall. So something else must be doing the work. To understand what that is, you have to let go of the idea that solidity is about matter being packed tightly together. Solidity has nothing to do with density in that sense. It has everything to do with forces, and more specifically, with one force you almost never think about: electromagnetism. Every atom is surrounded by an electric field. Electrons carry charge. Protons carry charge. Those charges create forces that extend outward through space. When you bring two atoms close together, their electric fields interact long before anything like contact could occur. And those interactions are not gentle, like charges repel. Electron clouds do not like being pushed into each other. They resist strongly. So when you stand on the floor, what actually happens is this. The electrons in the atoms of your feet repel the electrons in the atoms of the floor. That repulsion creates an upward force equal to your weight. That force is what you feel as solidity. You are not being supported by matter touching matter. You are being supported by fields pushing back. This already changes the picture completely. The floor is not holding you up because it is solid. It is solid because it holds you up. Solidity is not a substance. It is a behavior. Now notice something important. This repulsion happens without contact. It happens across empty space. The distance between atoms remains tiny, but non-zero. The support you feel comes from interactions that never require atoms to touch. So when you say you are standing on the floor, what you really mean is that your atoms are hovering above the atoms of the floor, held apart by electromagnetic forces. You are floating, not in a dramatic way, not visibly, but fundamentally. This should make you uneasy, because it means that hardness is not what you thought it was. Hardness is not a measure of how tightly packed something is. It's a measure of how strongly it resists having its electron clouds distorted. A diamond is hard, not because it is dense, but because its electrons are arranged in a way that resists deformation extremely well. Rubber is soft, not because it is empty, but because its molecular structure allows electrons to rearrange more easily. Solidity is about stiffness, not fullness. Now ask yourself this: if the floor holds you up using electromagnetic repulsion, why doesn't that force push you away violently? Why doesn't the floor launch you upward? Because force is balance. Gravity pulls you down. Electromagnetic repulsion pushes you up. When those two forces are equal, you stay where you are. Standing still is not the absence of forces. It is the presence of perfectly balanced ones. This means that at every moment you are standing, there is an enormous amount of activity happening at the atomic level. Fields pushing, Electrons resisting compression. Energy stored in distorted bonds. The floor is not passive. Neither are you. The sensation of solidity is the sensation of resistance. Now here's where this becomes even stranger. If solidity is just electromagnetic repulsion, why doesn't everything feel equally solid? Why can you sink into a mattress but not into concrete? Why can you bend rubber but not steel? The answer is structure. Different materials arrange their atoms differently. In some materials, atoms are locked into rigid lattices. In others, they're connected by flexible chains. In some, electrons are shared in ways that create strong resistance to deformation. In others, they can move more freely. The electromagnetic force is the same everywhere. What changes is how that force is distributed through the material. So when you press your foot into the floor pushes back, not just at the surface, but throughout its structure. The force spreads. Bonds stretch. The material resists collectively. That collective resistance is what you feel as solid. Now think about what this implies. You don't fall through the floor not because matter is solid, but because matter is organized. If the atoms in the floor were arranged differently, if their bonds allowed easy rearrangement, you would sink. Just like you do in water, sand, or foam. Those substances are not less real, they are just less resistant. So solidity is not a yes or no property. It's a spectrum. Everything resists. Some things resist more, and the reason they resist has nothing to do with atoms being packed together like bricks. It has everything to do with how fields and forces respond to distortion. Now pause and think about how counterintuitive this is. You feel solid. The floor feels solid, and yet neither of you is solid in the way you imagine. What you are feeling is not matter. It is interaction. You don't fall through the floor because the universe refuses to let charged particles occupy the same state in the same place. Because electrons resist being compressed. Because forces balance with extraordinary precision. Solidity is not built into matter. It emerges from the rules matter must obey. And once you see that, the question stops being, why don't you fall through the floor? It becomes, why does anything ever feel solid at all? Once you stop thinking of solidity as a property of matter and start thinking of it as a balance of forces, the world begins to look very different. The floor is no longer a rigid object beneath you. It is an active system, constantly pushing back, constantly resisting distortion. And so are you. Every atom in your body is doing the same thing. Your bones feel hard, not because they are packed with matter, but because their atomic structures resist being deformed. Your muscles feel soft, not because they are emptier, but because their internal bonds allow more movement. Hard and soft are not about how much stuff is there. They are about how that stuff responds. Now consider something that usually gets glossed over. If electromagnetic repulsion is what holds you up, then why doesn't gravity eventually win? Why don't electrons slowly compress under your weight until you sink? Because electrons are not passive objects, they obey quantum rules. And those rules impose limits that nothing can violate. One of those limits is especially important here. Electrons cannot all pile into the same state. They are forbidden from doing so. When you try to squeeze them closer together, you don't just get electrical repulsion. You get an additional resistance that has nothing to do with classical forces. It comes from the rules of quantum mechanics themselves. This means the floor resists you in two ways at once. Electromagnetic repulsion pushes back, and quantum constraints refuse to allow further compression. Together, they create an extraordinarily stiff response. That stiffness is solidity. You are not standing on a thing. You are standing on a prohibition. The universe is saying no at the most fundamental level. This also explains why solidity is so reliable, why floors don't randomly give way, why you don't occasionally sink a few centimeters into concrete and then pop back out. The rules enforcing solidity are not fragile, they are absolute. Electrons either obey them or cease to exist in any meaningful way. So the floor is not just resisting you, it cannot do otherwise. Now notice how this reframes the idea of emptiness. Atoms are mostly empty space, yes, but that empty space is not nothing. It is filled with fields, constraints, possibilities, and prohibitions. Empty space is structured. And when two regions of structured space interact, like the space around the atoms in your feet and the space around the atoms in the floor, the structure itself enforces limits. You don't fall through the floor because the structure of space around matter refuses to allow it. This is why the old picture of atoms as tiny balls is so misleading. Balls collide, balls bounce, balls touch. Atoms do none of that. They overlap fields, they repel configurations, they negotiate allowed states. Solidity is not collision, it is exclusion. And once you see that, a deeper question emerges. If the floor pushes back using electromagnetic forces, why don't you feel those forces everywhere? Why don't walls repel you from a distance? Why do you have to get so close before anything happens? Because electromagnetic forces are balanced on large scales. Atoms are electrically neutral overall. Their positive and negative charges cancel out at distances beyond the atomic scale. It's only when electron clouds begin to overlap, when configurations are threatened, that repulsion becomes dominant. So solidity turns on suddenly, not gradually, not gently. One moment, nothing. The next, resistance. That suddenness is what makes surfaces feel sharp and real, but it's an illusion of scale. At the microscopic level, nothing sudden is happening. Fields are interacting continuously. The change only feels abrupt because the relevant distance is so small. Now think about this. When you jump and land, the floor pushes back harder. The force increases. Why? Because you're trying to compress those electron clouds more rapidly. The faster you try to change the configuration, the stronger the resistance becomes. This is why falling from a height hurts. Not because the floor is cruel, but because the forces required to stop you grow enormous when the stopping distance is tiny. The floor doesn't choose to hurt you. It obeys the same rules as always. So solidity is not gentleness. It is stiffness. And stiffness comes from structure. Now let's turn this around. If solidity is just resistance to deformation, then it's not special. It's not fundamental. It's one possible behavior among many. Under different conditions, matter behaves differently. Heat is solid enough, and the bonds loosen. Resistance decreases. Solidity fades. The same atoms, the same forces, just arranged differently. Cool a liquid enough, and resistance increases. It becomes solid. Nothing new is added. Nothing is removed. Only organization changes. This should make you question something you probably never questioned before. Why does the floor feel solid now? Because at this temperature, under this pressure, with this structure, the balance of forces produces resistance strong enough to counteract gravity, change any of those variables enough, and the floor would not feel solid at all. So solidity is not guaranteed. It is conditional. You don't fall through the floor because, under ordinary conditions, the rules align in your favor. But the universe does not promise that alignment everywhere. Inside stars, matter behaves differently. Inside neutron stars, solidity breaks down entirely. At extreme pressures, electrons are forced into new arrangements. There, floors are meaningless concepts. What you call solid is a local solution to a local problem. And once you understand that, the everyday miracle of standing still becomes harder to ignore. You are not resting on matter. You are being held up by forces, rules, and constraints that operate silently and relentlessly beneath your awareness. That is what solidity really is. Once you see solidity as resistance enforced by rules rather than matter packed together, another illusion quietly disappears. The illusion that the floor is passive and you are active. In reality, both of you are equally involved in maintaining the situation. The floor is constantly pushing upward. You are constantly pushing downward. Standing still is not rest. It is negotiation. Every moment you remain upright, trillions of electrons in your body and in the floor are adjusting their configurations to maintain balance. Bonds stretch by unimaginably small amounts. Fields respond instantly. Energy is stored and released without you ever noticing. This is why solidity feels so reliable. It is not because nothing is happening, but because the same thing is happening over and over with astonishing consistency. Now think about what would happen if those rules were even slightly different. If electrons did not repel each other as strongly, matter would compress more easily. Floors would sag. Objects would sink. Structures would slowly collapse under their own weight. If electrons were allowed to occupy the same state freely, matter would lose its stiffness entirely. Everything would behave like a gas. There would be no solid surfaces to stand on at all. So the reason you don't fall through the floor is not accidental. It is encoded into the deepest rules of how particles behave. Solidity is not something added later. It is a direct consequence of quantum restrictions. This is why Feynman emphasized that to understand everyday phenomena, you don't need exotic forces or mysterious substances. You need to understand how the basic rules play out at large scales. Nothing special happens when you stand on the floor. The same interactions that govern atoms in a laboratory govern your weight on concrete. The difference is scale. At the scale of atoms, forces are enormous. Gravity is weak there. Electromagnetism dominates completely. That's why gravity never pulls you through the floor. It simply isn't strong enough to overcome the resistance created by electron interactions. Gravity shapes planets. Electromagnetism shapes matter. That division of labor is easy to forget because gravity feels strong to you. You feel your weight constantly, but weight is a large-scale effect acting on enormous numbers of particles. At the level where solidity is decided, gravity is almost irrelevant. This also explains why you can stand on a thin sheet of ice but fall through it if it cracks. The ice doesn't suddenly lose its electrons. It loses its structure. The forces can no longer spread out through a rigid lattice. Resistance collapses locally. Solidity requires connectivity. A solid object resists deformation because forces applied at one point are distributed across many bonds. Break those connections, and the resistance vanishes. So when a floor fails, it's not because matter stops being solid. It's because organization fails. That should make you reconsider what you mean by strength. Strength is not about mass. It's not about density. It's about how well forces can be distributed. Steel is strong because its atomic lattice spreads stress efficiently. Foam is weak because its structure collapses easily. Both are made of atoms. Both are held together by electromagnetic forces. The difference is geometry. This means solidity is not a simple property you either have or don't. It is a collective behavior emerging from how countless particles cooperate. You don't fall through the floor because an entire system agrees to resist you. Now let's confront the last uncomfortable implication. If solidity is emergent, then it is not absolute. Under extreme conditions, it can disappear. At very high temperatures, atoms vibrate so violently that bonds break, solids melt, resistance drops, floors become liquids. At extreme pressures, atoms are forced into new arrangements. Electrons behave differently. New forms of matter appear. In neutron stars, solidity as you know it does not exist. Matter becomes something else entirely. Degeneracy pressure replaces ordinary resistance. Floors are not just impossible, they are meaningless. So solidity is not a universal feature of the universe. It is a local phenomenon that exists because the conditions around you allow it. That realization should change how you see the ordinary act of standing. You are not supported by certainty. You are supported by balance, a balance of forces, a balance of rules, a balance that holds here, now, but not everywhere. And once you understand that, the question, why don't you fall through the floor, becomes more than a curiosity. It becomes an example of how deeply the abstract rules of physics shape your everyday life. You are not standing on matter. You are standing on the consequences of quantum mechanics. By now, the question has completely inverted itself. You no longer ask why the floor is solid. You ask why solidity exists at all, because nothing about the microscopic world guarantees it. Nothing about empty space suggests hardness. Nothing about particles demands resistance. And yet, here it is. So reliable that you rarely think about it. That reliability is what makes solidity deceptive. It feels like a basic feature of reality, something that was always there. But it isn't. It is an outcome, a result of rules interacting in a very specific way under very specific conditions. You don't fall through the floor because countless microscopic constraints line up perfectly to stop you. Electrons repel. Quantum rules forbid collapse. Atomic structures distribute force. Remove any one of those, and the floor would fail you. This means solidity is not something the universe guarantees everywhere. It's something the universe allows locally, and that distinction matters. Because once you see solidity as permission rather than substance, you start noticing how conditional it really is. Heat weakens it. Cracks undermine it. Pressure can overwhelm it. Organization can destroy it or reinforce it. The floor is solid only because, at this moment, its internal structure is intact enough to resist the forces acting on it. It is not unbreakable. It is not permanent. It is not fundamental. It is cooperative. And cooperation is fragile. That's why earthquakes are terrifying. Not because gravity changes, but because structure fails. The same atoms, the same forces, but the collective resistance vanishes. This also explains something quietly profound. When you press your hand against a wall, you feel the wall pushing back, but the wall feels your hand just as much. Forces are symmetric. Every push is met with an equal push in return. There is no dominant object in that interaction. No active side and passive side, only balance. So, solidity is not something the floor has and you don't. It's something that emerges between you. That's why you don't fall through the floor, but also why the floor doesn't fall through you. Now step back and let this settle. You live in a world where the most basic experiences, standing, sitting, leaning, depend on invisible negotiations between fields, and rules that you never perceive directly. You trust solidity without thinking, because it has never failed you. But it is not a given. It is a triumph of organization. And that triumph is temporary. Over long enough timescales, everything rearranges. Bonds break, structures erode, floors crack, mountains flatten. Even planets deform. Solidity is not eternal. It is persistent. That persistence is long enough for life, thought, and civilization, but not infinite. And this is where Feynman's way of explaining things quietly changes how you see the world. He doesn't tell you that the floor is solid because that's just how matter is. He shows you that solidity is a consequence of deeper principles, that nothing is solid by default, that the universe has no obligation to provide surfaces you can stand on. It just happens to do so here. And that realization does something subtle to your sense of reality. You stop seeing the world as made of things. You start seeing it as made of behaviors. The floor behaves like a solid. Your body behaves like a solid. But underneath, both are processes. Ongoing, dynamic, enforced moment by rules that never sleep. You don't fall through the floor because the universe is constantly saying no to that configuration. Not once. Not occasionally. But continuously. And it does so without effort, without intention, without awareness. Just rules, applied relentlessly. So the next time you stand still, notice what's really happening. You are not resting on something static. You are balanced on a living structure of forces, constraints, and responses. You are being held up by the same principles that govern atoms, stars, and everything in between. And once you truly understand that, the floor beneath you never feels quite as ordinary again. If this changed how you think about something as ordinary as standing still, comment solid below. I want to know what ideas surprised you most. Subscribe if you want more everyday experiences explained from the deepest level of physics.